The components shown are our motion capture system that is attached to the body. We have a inverted F meandered antenna shown below here. It has dimensions within the 30 by 30 by 5 millimeter specifications. The transceiver used here is an RFD22302 Bluetooth module, which is based on the Nordic Semiconductor NRF51822. Overall dimensions of the system are 3.5 by 3.5 by 0.6 centimeters. The system is fabricated on an FR4 1.6 millimeter thick PCB. The motion sensor used, seen in blue, is an MPU 6050. It has 6 degrees of freedom, 3-axis gyroscope, and a 3-axis accelerometer. The battery used in the system is a Maxwell CR2032 3-volt 220 milliamp hour coin cell style battery. The system is mounted to the wristband using Velcro as shown now.
Attached in front of the torso of the user is a central hub which has a Bluetooth Low Energy transceiver. To communicate with the Bluetooth Low Energy transceiver, we need a cell phone that supports Bluetooth Low Energy or Bluetooth 4. The cell phone that we have used is LG L80, which has support for Bluetooth 4, and this is our custom app that we'll be using to communicate with the central hub. In order to identify or discover the devices or active devices, we have to press scan, and discoverable devices will be shown in this window. The term RSSI means Received Signal Strength Index, and the tag GB_BAN is the advertising name of the central hub. Once we have discovered the device, we can connect to the device, and the system is programmed in such a way that if we send a non-zero value, it starts the calibration of the motion sensor and start computing the motion data. And we can send a 0 in order to stop the computation and display the computer data within the below field. Here we send a 1, and then the user will start his motion. Then in order to check, we send a 0. Here these are the computed values. So here we have the final value 89, which is computed using the angular velocity measured from the gyroscope.
We are now testing the back pocket test procedure for the device for the system. We've already connected to the device, and we're now going to be sending a 1 to start the data stream. I'm going to go ahead and start that. We're going to give it a couple of seconds for it to calibrate, and then he's going to continue his motion, and after that we're going to stop the data stream, and we're going to show you that the data has been sent and collected. Now that the motion's over, let me send a 0 to the system and show you that the data we do see is collected within the system, showing the gyroscope, angular change, and the acceleration of the wrist-mounted module. Good. We are now doing the third test procedure, which simulates the phone being in the front pocket of the individual. It is again already being connected. The device has already been connected to the phone, and we're going to start the data sending now. Give it a second to calibrate, and then we're going to have the individual do the test procedure. Now that the test procedure is done, I'm going to go ahead and stop the data stream and show you that we have received data on the accelerometer and gyroscope readings from the wrist module.